Hello friends, the question on three moment theorem asks like this: analyze the beam by using three moment theorem. The question asks in paper like this, that there will be 5 steps for solving three moment theorem. The first step will be the free bending moment. Free bending moment is calculated for each span, for span AB, for span BC and for span CD. Let's solve. For span BC, the bending moment at F. For span BC, the bending moment at F equals to WL square by 8. This is the bending moment for UDL. So by putting all the value, that is 3 into 4 square by 8, we get the 6 kilonewton meter. For span CD, here is a point load and the bending moment at G, means at point load the PAB by L. By putting all the value, we get the 6 kilonewton per meter. Here at the point A, the 3 kilonewton load is acting at point E, so it's create the moment about A. That's why the bending moment at A equals to 3 into 1, 3 into span length equals to its 3 kilonewton per meter. The second step was the drawing the free bending moment diagram. In this, what we calculated here, bending moment, just put this value on the diagrammatically form. So for span BC and for span CD, the bending moment we calculated, it is UDL. That's why the bending moment is like parabola, and area here calculated is 2 by 3 base into height. By putting value, we get the 16, and XL is the distance of centroid of this parabola from B, and XR is the centroid of this parabola from C. So it is 2 and 2. The bending moment diagram of point load is half into base into height. So by putting all the value, we get 9, and XL is the center of this triangle from C, and XR is center of this triangle from D. The third step was the bending moment theorem. This was the main step in the bending moment question. So for span ABC, we apply the bending moment theorem. That is the formula for this, that is M L1 upon E1 I1 plus twice MB in bracket L1 upon E1 I1 plus L2 upon E2 I2 bracket complete plus MC in bracket L2 upon E2 I2 plus 6 A1 X1 by L1 E1 I1 plus 6 A2 X2 by L2 E2 I2 equals to 0. This is a bending moment equation which is applied on every span. Here we calculated for span A, B, C. So by putting value, moment here we calculated for bending moment at A equals to minus 3 kilonewton meter, and length here calculated from A to B is designated as L1, and from B to C it's L2. So here by putting value of M1, we calculate minus M3 equals to L1 is 3 by twice E1 I1. Here takes twice I, that's why E into twice I. By putting all the value what we know, we get this equation, and by rearranging this equation, we get the 5.67 MB plus 1.33 MC equals to minus 115. Put it as equation number 1. The same bending moment equation is used for the span BCD, means for span BCD. So this is the bending moment equation for this span. So the known value, that is here L1 is from B to C and L2 is from C to D. By putting all the value what we know, we get the 1.33 MB plus 5.67 MC equals to minus 27.97. Put it as equation number 2. By solving equation number 1 and equation number 2 in Cal C, by giving simultaneous equation, we get the moment at B equals to minus 0.922 and moment at C equals to minus 4.711. Fourth step was calculation of reaction at each support. This was also the main step, because this step is necessary for calculation of shear force diagram. For calculating the reaction RA, we have to take a moment at B. So let's take a moment at B equals to this minus 3 into 4 plus RB into 3 plus 0.922 equals to 0. By solving this, we get the RA equals to 3.933. The similar procedure is applied for the remaining span. That is, for calculating the reaction at RB, we have to take a moment at C. So likewise, by solving this, we get the value of RB. That is, we calculated 4.358 kilonewton. Similar procedures for span R, for calculating the reaction at D and for calculating the reaction at C. By solving this procedure, we got the support reaction, that is RA, RB, RD and RC. So last and final step was a bending moment diagram. Here the question asks like this: this is the free bending moment diagram what we calculated earlier, and this is the actual bending moment diagram what we require. This is simply free bending moment what we calculated earlier, and this was the bending moment what we calculated by solving the three moment theorem. That is, we calculated the bending moment at B is 0.922 and bending moment at C equals to 4.717. So just this value put in this diagram and draw. This is bending moment diagram, and for shear force diagram we calculated the support reaction here. Just this value put in this diagrammatically form, we get the shear force diagram. Thank you.